So thank you for having me here. It's my first time to actually Houston proper and to your wonderful university. I'm based in Los Angeles, not Houston, so I've been learning a little bit this evening about some of the local challenges related to transportation in Houston. But what I'll present to you today related to urban air mobility and electric aviation is a global challenge and a global solution potentially. So what you can see in the graphic behind here is our new aircraft design, which is called the MOBI-One or Mobility-One, and it's a new type of aircraft, which I'll show you briefly in a video. My company is based in Detroit, Michigan. There's a very specific reason for that. The automotive sector does a really good job at producing high reliability vehicles, now shifting over to electric vehicles at a very affordable cost and in mass production quantities. So if urban air mobility becomes a new form of transportation for urban, suburban centers across the world, then having the ability to do things at mass production in the way the automotive sector does it can be quite beneficial to the space from a business perspective. I'm co-founder of the company and also a corporate officer, and my background is all related to engineering. And specifically, I spent the majority of my career in the space program, and I'm a huge fan of science fiction, and so you can see a lot of relationship between some of the technologies which have been proposed in the science fiction regime becoming a reality, whether that's ground-based travel, air travel, or space travel. So I'm a pretty big fan of that. And ultimately, I think somebody opened up with the fact that Houston is a center of innovation. Certainly many different urban centers across the world are a center of innovation. And when you see innovations in transportation, oftentimes they do happen in the entrepreneurial space as opposed to the big corporate entities. So a great example would be Tesla really has pushed forward electric vehicles, and now all the other automakers are following suit. And the same would go for aviation, where there are many small companies now in this electric aviation space to push forward the technology to facilitate a new type of air travel. And of course, the Jetsons is a great example of flying cars, and so our goal is to make that a reality. And what urban air mobility is actually thinking about travel, not just in 2 dimensions on the ground, but thinking about travel in terms of 3 dimensions. So adding the 3rd dimension of airspace, which ultimately will very rapidly reduce the congestion that we see on the ground as one potential mode of transportation. And since this is a commercial proposition, you do have to have a business case. And there have been many studies looking at the urban air mobility use case, both for passenger transport as well as cargo logistics, and it's a relatively large business opportunity happening in the next 10 to 20 years, which goes well over $1 trillion. So in terms of entrepreneurial ventures, being able to raise capital to support these aircraft developments from the engineering perspective, as well as the full certification, is kind of key to making that a reality. So I think I included a video, which I will briefly talk over. We are doing a fully electric, emission-free tilt-wing aircraft. So there's many different ways that you can facilitate the ability to take off and land vertically, which allows you to land in urban locations. But we also have a wing which functions as a traditional fixed-wing aircraft, which allows you to be more efficient during cruise. So this is one implementation. There are other companies who are offering different implementations. What you can see is an aircraft which is essentially an air taxi, which means that it carries 4 passengers as a regular taxi would, and then with a pilot. We are designing for autonomy, but we're still many years away from the FAA approving fully autonomous flight operation. So therefore, having a pilot in the loop makes sense from a safety perspective for a whole range of different use cases that you could potentially use it for. And in case you're curious, the video has the aircraft flying over Detroit in the background, which is where you can see the GM towers. So one of the things that people who aren't pilots aren't aware of is that there's actually quite a few general aviation airports across the country. In the vicinity of LAX, which is the international airport in Los Angeles, there's about 5. In the vicinity of Detroit, where our company is located, there's about 5 to 7. And those existing infrastructure assets are primarily used only by general aviation pilots, which means that they're very much underutilized. So being able to come up with an alternative platform, which doesn't require a long runway, as is the case of most jet aircraft, means that you can utilize these existing infrastructure assets as a means of providing city to city center travel and potentially regional travel as the aircraft are able to improve their range over time. But one of the big challenges for any form of transportation on the ground is the acquisition of land, is the right of way, is the cost associated with literally laying tracks and railroads and bridges. So being able to do something in the sky where it doesn't have an infrastructure aspect can allow you to have a path to market, a path to use relatively quickly, which is one of the arguments for urban air mobility. In terms of the platform that we're developing, you can see it here. It has a very attractive looking appearance because we have industrial designers who work on sports cars, but ultimately ultimately attractive aerodynamic design couples to more energy efficiency. And one of the big challenges of electric aviation is that batteries are quite heavy, which one of the speakers alluded to before, which means that you're very range limited. So for the initial aircraft that you'll see globally that are coming out, which are fully electric, they're limited to less than 100 miles of range, which means that only certain use cases can use them. And one of them is urban travel, urban to suburban travel, and then some close city pairs. And of course, anything related to emergency response, medevac, and high-value cargo logistics. But just as we've seen an improvement in battery technology over the course of the past decade because of additional use for electric vehicle drivetrains on the ground, that same improvement will allow these aircraft to eventually travel even longer distances. And of course, the goal is to have sort of regional travel on fully electric aircraft. In the meantime, you could have hybrid electric aircraft. And in terms of what we're doing as a company, we are trying to leverage the existing automotive sector, both from the electric vehicle drivetrain perspective, as well as from the mass production vehicle perspective. And one of the things that we were talking about a little bit earlier is that if we do see an increase in low altitude airspace traffic with urban air mobility, we will eventually need to have an update to air traffic control to support the higher densities of traffic. And there is a good analogy between V2X connected vehicle technology, which is used for self-driving vehicles on the ground, which could be used by these aircraft in the low altitude airspace. Moving forward, in terms of what this particular vehicle can do, it can carry 4 passengers and a pilot, or it can carry a passenger and 1,100 pounds of cargo. And so there are many different cargo use cases as well as emergency response use cases, which this would be an alternative for when you compare it to a helicopter, for example. And these type of aircraft, both from an operational perspective as well as a unit cost perspective, will be far more affordable. So what does that mean to you as the potential urban air taxi traveling public? We're designing the vehicles to facilitate a price point which would give you roughly a trip from a suburban airport to a major airport for $75 per seat, which is very similar to an Uber ride. So the intention of the customer base for the service wouldn't be just for executives of XYZ company, it would be for the full-on business traveling public as well as people who are trying to get across congested urban centers moving forward. User experience, these aircraft are not jet aircraft. They're flown in low altitude airspace, so between 1,000 to 3,000 feet above the ground, which means that you actually have a very nice view. So I'm not sure if any of you are sort of private pilots or instrument rated pilots in the room, but when you're flying at 1,000 to 3,000 feet above the ground, it's actually a really fun experience. It's quite different from commercial aviation where you're kind of stuck in the cattle car. So this would be very comfortable and roomy and a nice way to go. In terms of what we're doing as a startup is we're developing the vehicle from scratch. We've built many subscale aircraft. The largest one we have is built is 1/3 scale that you see here that they demonstrated over at the Uber Elevate Summit a few years back. And because these aircraft are fully electric, they have to be lightweighted, and our aircraft is 100% composite. So lightweighting allows you to be more energy efficient because you're carrying less payload in terms of your dry mass. This also couples to a ride-sharing platform, which is being developed by different providers. Probably the most famous one is Uber Elevate, but ultimately this form of transportation couples to the mobility as a service revolution that we see going around, whether it's car-based transit, and then hopefully, of course, we hope eventually air-based transit with urban air mobility systems. And so I think we're going to take the next 10 minutes, or I guess 15, 20 minutes, taking questions from everybody. Thank you.
Great.